Okay. Hello, friends of bio. Today, the first thing we'll do is a little review of radioactive decay, which is the very last thing we left off with before our extended break. So I'm just going to quick call it back to our last set of notes we took, our slideshow. And this is, we were talking about different ways we can tell how old a fossil is. Right, and the first way was relative dating, where we look at, these layers of rocks, right? And we can tell how old a fossil is relative to another type of fossil by looking at where it is in the rock layers. So we know that the oldest fossils, right, would be found in the bottom layer, right, the furthest down, okay? However, we last left off with the very last thing we did before break was our shoebox lab with the pennies, and that was not modeling relative dating, it was modeling radiometric dating, right, which is much more exact, okay, and with this we can get an estimate of the actual age of the fossil, and there's two things that we have to know, right, to do that. First of all, we have to know the amount of radioactive material. Okay, you have to know the amount of radioactive material that's in the fossil, and then we have to know right here the half-life. Okay, so we have to be able to know the half-life of the radioactive element. Okay, in order to guess an age of a fossil. So here's a little practice worksheet we're going to go through very concisely. And we're going to ask ourselves, well, what is half-life? Okay, so I will post this. We're going to walk through it together because you're going to have a little assignment, a little Google form that you're going to need to know how to interpret a graph like this. Okay, so all right, what is a half-life? A half-life, okay, is right here. Okay, so that's the answer to question 1. The half-life of an element means how long it takes for half of the material to decay, right? In this case, it's a fossil. And that radioactive element can be lots of things. Sometimes it's carbon-14, sometimes it's uranium. In our penny lab with the shoebox, the pennies were supposed to be potassium-40, but in this case, we're working with cesium. Okay, so cesium is our radioactive element. Okay, and we can actually tell what the half-life is of cesium by looking at a graph. So let's take a deeper look. So number 2 says, how much cesium did they start off with? Okay, we're just going to make an assumption here that this is, let's say that, this is grams here. This is the amount. So on our y-axis, we have the amount of the radioactive material in the fossil. And on the X, we have the time, okay? So here, we start off with, 100 grams of this cesium in our fossil, okay? How much is half of 100 is number 3. Well, we divide 100 by 2 and we get 50 grams, okay? And then we ask ourselves, how many years did it take to reach that point? So how much time did it take for the 100 grams here to go down to half that, 50 grams? And if we look at our graph and we extrapolate down, okay, we can see that that's about 30 years, okay, because our x-axis is in years. So there we go. And ladies and gentlemen, that is our half-life of cesium. So the number that you just found, okay, is the half-life of cesium. So let's answer these questions here. What is the purpose of this graph? Okay, the purpose of this graph is to determine to look at the decay, right? Look at decay of cesium over time. Okay. What is the x-axis? Well, that's our horizontal axis, so that's going to be time, okay, in years. Okay. What is along the y-axis, our vertical axis? That is the amount of cesium. Okay. And here's a couple more challenging questions. So, how long does it take for the 100 units of cesium to decay to be only 25 units of cesium? Make sure that you include your units. So we start off with 100, okay? And here, I'll use a different color. We start off with 100, right? And we know that it takes, right, 30 years to get to half that, and then to get to about 25, right, which is here, okay, it takes about 60 years, okay? So the answer is 60 years, which is actually, you know, what's next? Let's go to the next question, right? How many half-lives is this? Okay, so to figure out how many half-lives this is, well, first we have to know what is the half-life of the cesium. And we found that over here, the half-life of cesium is 30 years. So how many half-lives have taken place here? Well, we just do 60 divided by 2, and that equals, 60 divided by 30 years. All right, so our half-life is, or how many half-lives is this? This is 2 half-lives that have passed, okay? So if we know how many half-lives have passed, okay, then we can figure out how old a fossil is, right? If we know the amount of cesium left and we know how many half-lives has passed, we can figure out how old the fossil is. So a fossil that is, you know, that has 25% or 25 grams or a quarter, right? So this is 1/4. A fossil that has a quarter of its cesium left is going to be 60 years old, okay? A fossil that has 1/8 of its cesium left is going to be 90 years old, okay? A fossil that has 1/16 of its cesium left is going to be 120 years old, okay? And so on until, you know, this is 1/32 and there. But it all starts off with knowing the half-life, right, which is 30 years, okay? So you're going to use this help worksheet and this video to help you with your assignment, which is the Google form. Remember that the Google form, we want to open it in Safari, okay, and take it as many times as you need to get 100% so we could see our score. We open it in Safari, okay? Thanks, guys. See you soon.